Hello students, today's video is on vector. Vector is very important and simple topic. You get one question from this topic in G. I'm covering some important concept and previous year questions in this video. So stay tuned till end. Now product of two vectors. Scalar or dot product of two vectors is what A dot B and is equal to mod A mod B cos theta, where A and B are two vectors and theta is the angle between A and B. Now A and B be two non-zero vectors, then A dot B is 0 if and only if A and B are perpendicular to each other. That means angle between these two vectors is 90 degree, then cos 90 is 0. So in that case, A dot B is 0. So the condition for perpendicularity is A dot B is 0. Now if suppose this theta is 0, in that case cos 0 is 1. So what I get, A dot B is equal to mod A mod B into 1. That is A dot B is mod A into mod B. But if this theta is pi, and as we know that cos pi is minus 1, therefore A dot B is minus mod A mod B. The scalar product is commutative, that is A dot B is equal to B dot A. And since you know that I, j, k are the unit vectors along x, y and z axis, so I dot I, that is the angle between I and I is 0, therefore I dot I is equal to j dot j is equal to k dot k, and cos 0 is 1, therefore this is equal to 1. So I dot I is equal to j dot j is equal to k dot k is equal to 1. But angle between I and j is 90 degree, therefore I dot j is equal to j dot k is equal to k dot I is 0. And if you have to find angle between two vectors, so we can derive the formula from here that cos theta is equal to A dot B upon mod A mod B, which is written here. So theta is equal to cos inverse of A dot B upon mod A mod B. So this is all about scalar or dot product of two vectors. Now, if you have two vectors, that is A vector is A1I, A2J and A3K, B is what B1I, B2J, B3K, and if you have to find A dot B, so you can just find out by multiplying corresponding components. That is A dot B is what A1B1 plus A2B2 plus A3B3. So this is again scalar or dot product. And mod of A here, mod A square plus mod A2 square plus mod A3 square, mod of A1 square is what A1 square plus A2 square plus A3 square whole root is what mod of A. Mod B is B1 square plus B2 square plus B3 square whole square root. And since you know that cos theta is A dot B upon mod A square into mod B square, so this is written here, A dot B is A1 B1, A2 B2 plus A3 B3, and this is what mod A square, that is root of A1 square plus A2 square plus A3 square, and this is what mod of B square. Now next is written here vector or cross product of two vectors, and that is denoted by A cross B, and the formula is mod A mod B sine theta n cap. This is the diagram for angle between two vectors A and B is theta here, and n is here a unit vector perpendicular to the plane containing A and B, and A, B, N form a right-handed system as this is shown in this diagram. So A cross B is a vector quantity. A dot B is scalar quantity, whereas A cross B is a vector quantity. Let A and B be two non-zero vectors, then A cross B is 0 if and only if A and B are parallel or collinear. That means angle between them is 0, then sine 0 is 0. So what we get, A cross B is equal to 0. This is what the condition for parallelism or collinearism. So if you have to prove two vectors parallel, either you can prove A cross B is equal to 0, or another condition for parallelism is A is equal to lambda times B. Since direction ratios are proportionate, therefore this is another condition for parallelism which is more important. Now if theta is equal to 90 degrees, so we know that sine 90 is 1, so in that case A cross B comes out to be mod A mod B. Now I cross I, J cross J and K cross K is 0 because angle between them is 0 degree and sine 0 is 0, so we get this. But if we have to find I cross J, then we have to follow this. That means I cross j comes out to be k, j cross k comes out to be I, and k cross I comes out to be j. But if we move in opposite direction, that means if we follow j cross I, then my answer is minus of k, right? Similarly, k cross j is minus of I, and I cross k is minus of j. If we move in opposite direction, then we get negative sign here. So cross product is not commutative, as you can see here, where dot product is commutative. In terms of vector product, the angle between two vectors a and b may be written as sine theta a cross b whole mod upon mod a into mod b. So what we conclude from here, condition of perpendicularity is a dot b is 0, and condition of parallelism is either you prove a cross b is equal to 0, that is cross product is 0, or we can use this equation that a is equal to lambda times b. Both are condition for parallelism. If we get vectors in this form, that means a vector is a1i, a2j, a3k, and b vector is b1i, b2j, b3k, then their cross product is, we have to just solve this determinant. A cross b is, you just have to write ijk, and here we write the components a1, a2, a3, b1, b2, b3, and when we solve this, we get the cross product, which is a vector quantity. Now here are the applications. Just simple application here, which came in 2002. What is given here? Mod A is given to be 4, mod B is here 2, and angle between A and B is here pi by 6. We have to find A cross B whole square. As we know, cross product is mod A, mod B, and sine pi by 6, and just we have to square it. And mod A is given to here, and further we can write this mod A square, mod B square, sine square pi by 6. Mod A is given here 4, so this comes out to be 4 square. Mod B is here 2, so we write here 2 square, and sine square 30 degree is 1 by 2 whole square. So what next I get? So my answer is only 4 square, that is 16. So this is the simple application of cross product. Now next, in this question, mod A, B, C are 3 vectors, and A plus B plus C is equal to 0. Further, mod A is 7, mod B is equal to 5, and mod C is equal to 3. These 3 quantities are given to us. And we have to find angle between B and C. So we start with the given condition, that is A plus, first of all, just write all the conditions which are given to us. So mod A is here 7, mod B is here 5, and mod of C is here 3. And you should know that squaring is the solution of these types of question. You can just rewrite this as B plus C is equal to minus A. Why? Because if I square, in that case I get B dot C, and in dot product we have angle cos theta. Since angle, we have to find angle between them, so B plus C remain on left hand side. After squaring, we get B dot C, where we can use the angle between B and C. So just square it. So what we get here? This is what mod B whole square, this mod of C whole square is 2B dot C is equal to, so this is 5 square, as mod B is equal to 5. Mod C is 3, therefore this is 3 square, that is 9. And as we know, dot product is mod B, mod C, cos of theta, and A square is here 7 square. So what I get, 2 mod B mod C cos theta is 49, and here I have 25 plus 9, that is 34, and if I take these two terms to this side, so this comes out to be minus 34. On further solving, what I get, 2 mod B mod C cos theta is equal to 15. This is 5. And just I replace the value here. So 15 gets cancelled out with each other, and what we get, cos theta is equal to 1 by 2. So theta is here 60 degree is the correct option. So my A option is the right answer. So this was a simple application of dot product. Now in this question came in 2008. The non-zero vectors are A, B, C are related by this equation, that A vector is equal to 8 times B and C is minus 7 times B. Then the angle between A and C, we have to find angle between A and C. So we have to relate A and C with each other. Just write the given condition, A is equal to 8B and C is equal to minus 7B. We have to use these equation and find the angle between A and C. So what I do, from equation 2, I get B is equal to minus C times 7 and just put this value in equation 1. So from here what I get, 8 in place of B, I am just substituting this value. So that is minus C by 7. On further rewriting this, I get this. And since we know that this is the condition of parallelism, as we have already done, that if A and B are two parallel vectors, so condition of parallel, because if A is parallel to B, so what we get, A is equal to lambda times B. Similarly here, what we get, that A and C are parallel vectors. So A is parallel to C, but as we get minus sign here, so that means these two are parallel and are in opposite direction. So that means if these two are parallel and in opposite direction, that means angle between them, between A and C, is pi, because cos pi is minus 1. We have already done this. So D is the correct option here. If A and B are two unit vectors such that A plus 2B and 5A minus 4B are perpendicular to each other, then we have to find angle between A and B. So first of all, we have to write all the given conditions. What is given here? A and B are two unit vectors. That means mod A is equal to mod B is equal to 1. What next is given here? A plus 2B and 5A minus 4B are perpendicular to each other, and condition of perpendicularity I am using here. That means if these two are perpendicular to each other, then their dot product is 0. So I'm just equating their dot product. That means A plus 2B dot 5A minus 4B is equal to 0. On opening this bracket, what I get, 5 mod A square, because A dot A is mod A square. And further I get minus 8AB plus 10. So no, I get minus 4AB plus 10. So that is 6AB, 6A dot B. And on multiplying 2B with minus 4B, we get minus 8 mod B square is equal to 0. Now, since A and B are unit vectors, so what I get, 5 into 1. Here I use dot product, that is mod A, mod B, cos theta, minus 8 into 1 is equal to 0. So 5 minus 8 is minus 3. And if I take this minus 3 to right hand side, I get plus 3 here. On further solving, 6 into 1 into 1 cos theta is equal to 3. Cos theta is equal to 1 by 2. So theta is equal to pi by 3. That is 60 degree is the correct answer. So now we are raising the bar. Now next question is this. A vector is 2i plus j minus 2k. B is I plus j. And if C is a vector such that A dot C is mod C, mod of C minus A is 2 root 2. And we have to find angle between A cross B and C. No, angle between A cross B and C is given to us 30 degree. And we have to find A cross B cross C. So since angle is given to us, so between A cross B and C, first of all, we write all the given conditions. A is given to us 2i plus j minus 2k. B is here I plus j. And relation between A and C is given to us that A dot C is mod C. Further, C minus A whole mod is given to us 2 root 2. Further, one more thing is given to us, that is angle between A cross B and C is 30 degree. And what we have to find? We have to find A cross B cross C. This is what vector triple product. But since angle is given between A cross B and C, therefore we just use the formula of cross product, that was mod of A cross B, mod of C, and angle between them, that is sine of 30 degree. We can find out A cross B using determinant. Sine 30 is 1 by 2. What we have to find here mod of C using these given equations. So how we relate these? Since C minus A, just denote this by equation 1, is 2 root 2. As I told you, squaring is the solution of most of the question vectors. Just do squaring here. What I get? Mod C square plus mod A square minus 2A dot C is equal to 8. Now, if A vector is 2i plus j minus 2k, then mod A, since I need here mod A, so is what? 2 square plus 1 square minus 2 whole square. So this comes out to be root of 9, or that is 3. So I'm just substituting the value of mod A square here. This is mod of C square. Since mod A is 3, so that whole square is 9. And one more condition is given to us, that is A dot C is mod C. So I'm using this condition that A dot C is mod C here. So this comes out to be mod of C is equal to 8. Mod C whole square minus 2 mod C, and 9 minus 8 is plus 1. And this is my identity, that is mod C minus 1 whole square. X minus 1 whole square is x square plus y square minus 2xy. So this comes out to be mod of C whole square. I'm taking root. What I get? Mod C is equal to 1. So now we are done with this. Just we have to put this value in equation 1. But what else we need? I need A cross B. And as you know, A cross B is just solving this determinant, that is I, J, K, and since A vector was 2i plus j minus 2k, so I write here 2, 1, minus 2, and B vector was I plus j, so I write here 1, 1, and 0, and rest what I have to do, I have to just solve this determinant. What I get is 0, minus of minus 2 plus 2, minus j, this is again plus 2 plus k, and this is 2 minus 1, that is 1. So this comes out to be 2i minus 2j plus 1. And this is what A cross B, but I need mod of A cross B. So that is 2 square minus 2 whole square plus 1. So this is root of 9 and this comes out to be 3. Now what I have to do, I have to just substitute the value of mod C, that is 1 here, and the value of A cross B mod, that is 3 here. So on substituting these values, put in equation 1. So what I get, I have to find this. So I'm just substituting the values. This is 3, this is 1, and this is 1 by 2. So my answer is 3 by 2. So my correct option is here, option B. So this question came in 1999. The similar question was asked in 2017, and using same equations are given to us. We can, in this case, we have to find A dot C. So we can easily find out using all these given conditions. Next. Again, very important question, came on 10 January 2019 mains exam. A is 3, 0, minus 1, B is 2, 10, 6, and C is a 1, 2, 1. Be the vertices of triangle ABC. And M is the midpoint of AC. If G divides BM in the ratio 2:1, then cos angle of GOA, where O being the origin, is equal to. Since this G divides BM in the ratio 2:1, and M is the midpoint, and as we know that BM is the median and G is here centroid, and because centroid divides median in the ratio 2:1. So this is what G is here centroid, BM is here median, and using the property that centroid divides median in the ratio 2:1, twice is distance from vertex and once is the distance from side. So we use this concept to find angle between GOA. As we know that the vertices of centroid are x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3 is what the coordinates of centroid, if all the three vertices are given to us. As A given to here 3, 0, minus 1, B is here 2, 10, 6, and C is here 1, 2, 1. So the coordinate of the centroid, that is G, is here using the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3 comes out to be, this is 6 upon 3, that is 2, 12 upon 3, 4, and this is 6 upon 3 again 2. So these are the coordinates of centroid G. What else we have to find? We have to find cos of angle GOA. So cos of angle GOA using the formula of cos theta, that is mod A, that is A dot B upon mod A mod B. In this case, we have OG dot OA upon mod OG upon mod of OA, where O is here origin given to us. Now, since G is 2, 4, 2, coordinates of centroid 2, 4, 2, so OG is here 2I 4J plus 2K, and mod of OG is here 4 plus 16 plus 4, that is root of 24. OA, since vertex of OA are 3, 0, minus 1, so OA vector is here 3I 0J minus of K, and mod of OA is here 3 square plus 1, that is root of 10. Now just we have to put all these value in equation 1. OG dot OA is what the dot product using components. So cos angle GOA is OG dot OA, that is 2 into 3, so that comes out to be 6. 4 into 0, so that is 0. 2 into minus 1, so that comes out to be minus 2 upon mod of OG, that is root 24 into root of 10. So what I get, this comes out to be 4 upon root of 24 into 10. So what we get from here, this comes out to be 4 upon, this is 4 into 6, so therefore this is 2 root 6. And here I get, and further solving, so what I get from here, if I take root 2 common in denominator, so what I get is 1 upon root of 15 is the correct option. So answer is here A option. Now next. This is again very important concept. Projection of a vector on a line. So projection of A on B is what the dot product of A with the unit vector V, or further we can write that A dot B upon mod B, because unit vector B is B upon mod B. I just replace it by this B upon mod B. So this is what projection of A on B. Similarly, you can find projection of B on A is, of B along A is dot product of B with unit vector A, or B dot A upon mod of A. But next, projection vector of A along B is what the dot product of this projection with unit vector B. On further solving, we can write that projection vector of A along B is a vector quantity, and that is A dot B upon mod B whole square into this vector B. So this is the formula for projection vector of A along B. This is the formula for projection of A along B. This is scalar quantity. This is vector quantity. Now here is the application. One more formula is written here, which I will discuss in my next video also. But since we are using this formula, therefore I have written here scalar triple product. These are three vectors AI, A2j plus A3k, B vectors B1i, B2j, B3k, and C vectors C1i plus C2j plus C3k. And the scalar triple product is A cross B dot C, or can be written like this. And how we find this? Just we have to solve this determinant and we get the scalar quantity after solving this. And this is known as scalar triple product. Or this is also the condition of coplanarity of these three vectors. That means these three vectors lie on a same plane, which we'll discuss in my next video. Now look. Again, very important question. If X vector is given to us here, just I'm rewriting the given condition. We should write all the conditions which will make easy to find the correct answer. So just write all the given conditions. So I have written all the values of three vectors. So X, Y, and Z are given to us. Then the magnitude, we have to find the magnitude of projection of X cross Y on Z. Projection of, that means, as I already told you, projection of X cross Y along Z is X cross Y dot Z upon mod Z. In this question, I have to find its magnitude. So, magnitude of projection of X cross Y along Z is just mod of this. As I already discussed you, the scalar triple product is the determinant of these three vectors. So just I have to solve this. So I'm just finding the scalar triple, that is 3 minus 6 minus 1, 1, 4 minus 3, 3 minus 4 minus 12. And on solving this determinant, I get 3 minus 48 minus of 12 minus minus plus 6 minus 12 plus 9 minus 1. This is minus 4 minus 12. This is 3 minus 60, that is minus 180 minus 18 plus 16. So this comes out to be minus of 182. And mod of z is here, which I have to use in my equation 1. So mod z is here, so z is given to us 3i minus 4j minus 12k. So this is 3 square plus 4 square plus 12 square, that is 9 plus 16 plus 144, that is root of 169 is equal to 13. I'm just putting all the values in equation 1, and after putting these values in equation, what I get, minus 1 upon minus 182 upon 13. So that is 14 is the correct option. So my right option is here, option C. So this is what the use of projection of A along B. Another application which came in 2020 J exam. In this question, the projection of the line joining the points 1, minus 1, 3 and 2, minus 4, 11 on the line joining minus 1, 2, 3, 3, minus 2, 10. So first of all, write all the points. One point is P, 1, minus 1, 3. Another is Q, 2, minus 4 and 11. The third one, if I take R, so that is minus 1, 2, 3. And next I take S, that is 3, minus 2 and 10. So what I have to find in this question, the projection of line joining PQ on the line joining the points RS. So PQ vector is here 2 minus 1, 2 minus 1, that is I cap, minus 4 plus 1, that is minus 3j cap, then 11 minus 3, that is plus 8k cap. And similarly, RS vector is 3 minus minus 1, that is plus 4i, minus 2, minus 2, that is minus of 4j, and 10 minus 3, that is 7k. Projection of, just simple application of projection formula, projection of PQ on RS is PQ dot RS upon mod PQ mod RS. So this is what the component, so 4 into 1, that is 4, minus 4 minus 3, that is plus 12, 7 into 8, that is 56, upon mod of PQ is here, no, I just need this is projection. So that is PQ dot RS upon mod of RS. So I need here mod of RS only. So that is 4 square plus 4 square plus 7 square. That is 16 plus 16 plus 49. That is 32 plus 49 is what, root of 81, that is 9. So what I get here, 72 upon 9. So my answer is 8 here. So this fill up is filled by 8 only. Next. Let A vectors I plus j plus root 2k, B is b1 plus b1i plus b2j plus root 2k, and C vector is 5i plus j plus root 2k. B3 vectors are that projection vector of B on A is A. This question is of projection vector of B on A. If A plus B is perpendicular to C, then mod B is equal to, we have to find, this question came on 9 January 2019 JEE. Now first of all, write all the given equations As A is given to us I plus j plus root 2k, B is here b1i plus b2j plus root 2k, and C is here 5i plus j plus root 2k. The three vectors are the projection vector of B on A is A. That means B dot A upon mod of A square dot A is A. So we need here B dot A, that is the cross dot product of B dot A, and further, so what I get, B dot A is B1 into 1, that is B1, plus B2 into 1, that is B2, and root 2 into root 2, that is 2, and mod of A square is here 1 plus 1 plus 2, that is root of 4. So here I get mod A square is 4. What next I get, B1 plus B2 is comes out to be here 2. So I denote this by equation 1. What next is given, I have to write that A plus B is perpendicular to C. That means I have to use the condition of perpendicularity, that is dot product is 0. And further, what I have to find, mod B is equal to. For that we need B, and for that we need B1 and B2, values of B1 and B2. So I am using the next condition, that is A plus B. First of all, we find A plus B. So as A was, I am just rewriting here, I plus j plus root 2k, and B vector was B1i, B2j, and root 2k. So A plus B is B plus 1i, B1 plus 1i, B2 plus 1j, and root 2 plus root 2, that is 2 root 2k. Since A plus B is perpendicular to, so this vector is A plus B is perpendicular to C, so their dot product is 0, and C vector is here 5i plus j plus root 2k. So their dot product is this component to component product, that is 5b plus 5, this b1, sorry, 5b1 plus 1, 1 into b2 plus 1, and 2 root 2 into plus 2 root 2 into root 2 is equal to 0. 5b1 plus 5 plus b2 plus 1, and that is 4. On further solving, I get 5b1 plus b2 and plus of 10 if I take this to this side. So this is my equation 2. Now just I have to solve equation 1 and 2. Solving 1 and 2, what I get? So if I subtract this, I get 4b1 minus 12. So b1 comes out to be minus 3 on putting this in equation 1. That is b1 plus b2 is equal to 2. So I get b2 comes out to be 5. And now my B vector is, I'm just putting the value of B1, B2 there. So that is minus 3i plus 5j plus root 2k, and its mod is mod B is mod B, 3 square plus 5 square plus root 2 square. So this is 25 plus 7 root of 36. So 6 is the correct option. So my correct option is here, option A. So I'm sure you have gained a lot from this video. I will catch you guys very soon with more videos on this topic. Please like and share it with people around you, and subscribe my channel method wise. Thank you.